WarsawJS.
So good morning, everyone. Over the past couple of months, I've been working on a project and I learned quite a bunch. So I wanted to share these learnings with you. But first things first, let me introduce myself. My name is Kacper and I've been programming for more or less 9 years, mainly in TypeScript, Go, and C++. I am a game jams enjoyer, which means I like making games usually over the course of the weekend. It's super fun. Strongly recommend you to get interested in that. I've been also a part of this beautiful community since 2016. And currently I work in email security and at Redshift, which is also super fun. And let me tell you about this project. So it's called Space Repetition. And basically, it's just an app for reviewing flashcards and actually memorizing them. It's using what is called space repetition method, which is some optimized way of retaining information over time. So basically, the algorithm under the hood called super memo makes sure that you only review the card again when you really need it, based on the answer, how well you have remembered it. And it has a quite a simple set of features. You can add, edit, and delete flashcards. You can import them from a CSV file if you want to add a bunch, and run memorizing sessions, which is like basically select 10 cards at random and memorize them. And when I started working on that, the architecture was quite simple. I started with a Golang server, so like old school server-side rendered application like you would in PHP, 20 years ago. So it also had a embedded database, meaning that it didn't talk to an external server for a database. My Golang process would have the database. A typical embedded database used, or the most popular one, is SQLite. I used something called BudgetDB. It's not really relevant. My point is that it was really simple because it was all a single process. And the web browser would just make a request to my server. It would return HTML. And then if I wanted to modify something, I would, again, send a form to my server and it would reload the whole page with a new HTML. Simple as that. And when I wanted to deploy that, I actually realized that I need to make some changes. So I realized that, okay, it's a single process for all the users, and obviously my app is going to be super popular. So I need to scale. And a single process with an embedded database is limited, first of all, to a single machine. So it has its limits when it comes to scale. So I was like, no, I need to make multiple instances on my server. I also want zero downtime. If one of the instances is down, I want others to work. It's not really required when you're making a project for less than 1,000 users, or even 10,000. But I think it was more my backend engineering ego that just wouldn't let me have a single point of failure in my whole project. So I changed it a bit. The version 2 of my architecture would have multiple instances. So now you can see that I have 2 instances of the same server, and now they couldn't have only a single embedded database because they would have to share a file system, meaning that they either would have to be on a single machine or use like a virtual file system. But the way I could do it in my cloud provider is I couldn't make them share an embedded database. I'm not really sure actually whether it's easy to share an embedded database on a single file system. With the one I was using, it wasn't possible at all. I could only have a single process, have a lock on that directory with the database, and that's it. So that forced me to have another database, PostgreSDB, served on another server. Yeah, so it's became scalable. I saw how one instance failed, and the other would continue working. That's beautiful. I was really proud of my application, but I realized something. No spoilers. I realized something that my users who actually started to use the app at this point are based in different locations in the world. For example, in the US or in China. And my whole app is hosted from a data center in Warsaw, which makes a beautiful experience for myself and my friends based in Warsaw and in Poland and in Europe even. But now when you have to go across the ocean via, the underwater cables, we experience what is called latency. So basically, the experience for the users a bit farther from Europe would be much slower. So I thought what I can do to improve that, and basically I just set up more instances on my app, but now in not only in Warsaw but also in Texas. So this alone wouldn't do much, because basically every request would still have to talk to the database, which I have a single instance of. So apart from having instances around the world, I also introduced what's called optimistic responses, which is basically I would answer to the user, if I could do that, before I got the answer from the database. So basically the calls to the database would be asynchronous, and HTML would be returned as soon as I have anything that the user can see. Obviously that cannot be done for everything. So basically we need to start caring about consistency with optimistic responses. So it's not a silver bullet, but in that case it made a really nice experience for the user, and it was fast. It was fast globally because of that change. My app was fast, and my happiness didn't last for long, because I got an unpleasant email from my cloud provider, which is that my database crashed. On this picture you can see how everything is like multi-instance, beautiful, but my database is a single instance, right? So if it's down, everything is down, and this was really frustrating for me. Like I wanted to make this app to share something cool I made with other people, and now I started like waking up in the middle of the night, checking whether my infrastructure is still up. I didn't sign up for being a operations team for like a global user base. So I started thinking deeply about it, and I think I finally got the true meaning of the little prince, which basically says that I became responsible for what I have obtained, which is my users. They depend on me, and if I let them down, meaning if my infrastructure is down, they cannot use the app. So I didn't want that responsibility. Like I want to make something and forget about it. And I remembered I actually made a project like that a while ago. It was called Recipe Box, which was made around 7 years ago. You can see it's an app created to quickly manage recipes written in React.js. It uses browser storage, so the recipes are kept in memory even when a user restart the browser. So what it means is that all the operations were done locally and then persisted to local storage. And in ways, this application was actually better than what I did this time. So it was just a front end app. This is exactly how the architecture looked like. It only had a static file server, just would host HTML, CSS, and JavaScript. Then it would just have a single network request for that, and anything else would happen in the web browser locally for the user with no latency. So basically, my problems weren't there. The problems I experienced with this project, my local environment was the same as production. I didn't have to like scale in some ways to take care for the growing traffic of the users. Also, the latency wasn't there at all, because once the HTML is shipped, it just works inside of the browser and JavaScript. So yeah, I didn't have to care about that at all. And also, I didn't have to worry about my infrastructure being down, because static file servers are pretty robust technology and quite simple. Most importantly, they do not contain my code and my configuration. It just works, because it's battle tested. It's proven, and I don't have to worry about it at all. So I realized there's one thing, or actually two things that I learned throughout these years. And after all, my app is not, my new app is not that bad, because it offers something that Recipe Box couldn't offer, which is sync and backup. Recipe Box, unfortunately, even though it was magnificent, it didn't offer the backup for the user. So if they would lose their device, it wasn't persisted to any external database. And also, if they had multiple devices, they wouldn't be able to sync those changes. So a centralized database has its perks, but after some time, I came across a manifesto which says that it is possible to make applications that work primarily locally and do offer sync and backup, even in real time, which is this concept of local first software. Basically, apps like Google Docs or Google Sheets, they very much work real time when you collaborate in them, and they do not work perfectly offline. But the authors of this manifesto, they have actually attempted to make software that's very similar to these tools, and it actually works offline very well, and also syncs in real time. So it's a very interesting technology under the hood that allows for that. I don't have time to speak about that today, but the idea is somewhat like this. We have a static file server, again, just to have our HTML and JS and CSS sent over the wire to the browser. Then if we want to be fully offline, or have full offline support, we could cache that in a service worker here, and then all the operations would happen to the local database. Typically, it would be an IndexedDB, which offers a bit more capabilities than local storage. And then this database would talk with the sync and backup server that would ensure that all the clients are in sync, and that the changes are persisted to some external database. And I like this architecture because what I care about as a developer, I only care about the piece on the right, about the orange elements. There are my application, but I don't have to worry about writing the static file server or the sync and backup server because they're quite universal in its logic. They're what I would call business logic agnostic. So they only achieve specific tasks, and I need to only write the front-end application. So this is an example of a React application. Nothing new, nothing surprising here. We have a local state of ToDos. We have an input, and we can basically, we can add a to-do, which would just append to our array, like call set ToDos with the appended item, and then reset the input, and then we render that. Nothing surprising here. If you know React, it's like second nature to use this code. And we can see this up, obviously, when I refresh the page, my data is gone. And if I open the same page in the other browser, on the bottom we have Firefox. On the top, this is Chrome. We can see that they're not in sync. But with a couple of changes, using YJS, which is currently the most popular local first applications framework, I can change that. So if we look at the code, we can see, let's only watch the parts when we modify the to-dos. So right now, we no longer set the to-dos array directly. We just execute an operation on Y to-dos. And Y to-dos, we can see it's something that we inherited from the Y doc. We call it get array to-dos. And what it does is Y to-dos will record all the changes done to this object. So if they push, it will know we pushed something. And then on the other side of the pipe, let's say, we have observe. So then if we want to listen to any changes made to Y to-dos, we just set this callback, and now we know that Y to-dos was updated. So in this way, we nicely capture all the changes made to our to-dos. And it happens so that it's trivial at this point to add things like persistence and sync and backup. So we can see we have IndexedDB persistence here and WebSocket provider that achieve exactly that. That basically, if I refresh the page, my changes are still here. And if I make changes to one instance, they are reflected in the other instance as well. And as I mentioned, I didn't have to write this server that runs here. It's just a standard WebSocket server provided by YJS. So yeah, it's very promising in my opinion, this paradigm. But as with a lot of technologies, we have multiple options. YJS is, as I mentioned, the most popular one. It's quite old. I think it's around 8 years or 5 years. Not sure, not quite sure. But it's been around for quite some time. And we have a new player in the game called AutoMerge. It was actually written by the guys from the Manifesto. And it looks very, very promising, but actually the landscape is much more complicated than that. We have really, really interesting tools, Tinybase, Electric SQL, I think GunJS, like they all have different pros and cons. Obviously, they are growing rapidly, but they're quite immature. So there's no silver bullet. If you want to build an application like that, you will have to do your own research. But I would start with these two, YJS and AutoMerge. So now, when I got you, all hyped up about local first software, now let's get real. Let's think about what would actually happen if we started writing an application like that. So Obviously we get a couple of pros, which is application interactions are instant, which is really what brought me here. Like I hate web applications that are sluggish and that we have to wait for something to happen a couple of seconds. Like the user feedback should be instant. Like I don't care that developers, they use this framework and now they need to wait for the backend to respond. Like I would like my apps to be instant, and it is possible. And offline support, again, if I'm on an airplane and I just want to work for a bit, and I open up my Jira, suddenly the page I have just opened on the airport is gone, just because I don't have internet connection. But this data could be stored on my device and I could access it because I have already accessed it, And we have very big storage capacity these days. We have huge like SSD disks, and it's all there. Superior developer experience. So as you see, now the local first paradigm allows us to only focus on the front end. This doesn't mean that like backend skills aren't relevant anymore. It's basically saying that we have a single application that is now doing the job of both the front end and the backend, because the sync layer will handle all the network traffic, but we still have to think about designing our data schema. So if you work with like Firebase, you have similar challenges there. The only difference is that Firebase is not local first, but it provides this sync layer. But yeah, the applications that you made in the local first paradigm are they have the potential to be made much faster because of that. And it's easier to keep your app alive. As I mentioned, your app, first of all, it works offline. So it's like if something happens to your backend, the user can still use it. Obviously, some functionality will not be there because they cannot sync with others, but they can use the app open and access their data. And also the backend components now are much simpler, like much easier to scale. You don't have to think about, where do we store state, and basically the backends are more agnostic to your specific application. And because of that, we also have lower infra costs, because possibly a lot of operations can just happen locally and then synced in the background without this pressure to something happening fast on the back end. Cons: business models may not survive this change of paradigm, because like if you can access your application offline, you can use it forever, even if you're not paying for that, because like the people who sold this app to you now, they have no way of knowing whether you're still paying or not, because you don't have internet connection. So obviously this makes any kind of fraud much easier in this area. So probably the business models should move to something like that the sync features are more something that we would pay for rather than the access to the application. And the paradigm shift in general is a problem, because we are used to one way of thinking about our apps, like there's a REST API or a GraphQL or something like that, and we talk to our backend. There's a centralized database. Now you're dealing with a distributed system. You have many databases that synchronize with each other. So thinking about stuff like migration of data, that clients can have outdated versions of both the data and the code, so something like backwards and forwards compatibility start to appear here. So yeah, it's something that we will have to get used to if we want to get into this direction. No strong data consistency. So because all the data operations happen instantly, uh, it means we have no way of knowing if everyone meets at the same place. Like uh, imagine you're building like a ticket selling system, and you want to make sure that only one person can buy a single seat. In local first, uh, two people will be able to book the same seat, and then after some time they would synchronize with each other, and one of them will find out that, oh, unfortunately, even though you have reserved your seat, it's been taken away from you. And we don't want that. That's a really poor user experience. We want strong data consistency in these scenarios, which is usually achieved by database transaction and consistency enforced on the side of the database. So another con is obviously if we store a lot of data on the user device and do all the computation on the user device, low spec devices might suffer. So the lower infra costs, they do not come from nowhere. They are just moved to the users. The ecosystem is still young, so if you want to base your entire project or business strategy based on the local first app, then you'll probably have to build a lot of stuff yourself. So this is something to consider. And yeah, this is really all I prepared for you. Thank you for your time, and see you.